Good afternoon. Today we're talking about modeling exponential and power functions, which means writing equations for these functions. We're going to do it in two ways. The first thing we're going to look at is doing these by hand, for which we'll need 2 points and the guarantee that our graph needs to pass exactly through those 2 points. Then we're going to do it using regression on our calculators. Here you'll get a whole table of values, and what you're doing is trying to find the function that most closely goes through all the points. It doesn't actually have to pass through any given ones of the points. It's the best fit that you can make using the table given. Let's get right into it. So when we do these by hand, let's start with an example involving an exponential model. For this, we'll need 2 points, and again, these are exact points. That is, our graph is going to pass directly through these points. We're going to use 110 and 480 as our 2 points. The basic formula for an exponential model is y equals a times b to the x. Notice the x is the exponent, which is why we call this exponential. Our basic strategy here is to use these 2 points to generate 2 equations, so that we can find the values for a and b, our 2 unknowns. In this case, we fill them in for x and y. So y is 10 when x is 1, and y is 80 when x is 4. There are books or teachers who will tell you to use substitution, so we would solve these both for a and then put them equal to each other, which we could do. I like something more like elimination. We did in chapter 3. We eliminated by adding 2 equations together. This time we're going to divide. So I'm going to take my 80 equals a times b to the 4th, and I'm going to divide the left side by 10, and divide the right side as a times b, because the first equation guarantees those are the same. So I divided the same thing on both sides, even though it looks different. 80 divided by 10 is 8. Here the a's cancel, leaving 1, and b to the 4th divided by b to the 1st, you subtract the exponents, you get b to the 3rd power. If b to the 3rd power is 8, we're looking for the cube root of 8, which is 2. Now that I know b is 2, I can come back up to my first equation, and if b is 2, then a has to be 5. If you need to write that equation, you can. 10 equals a times 2. Divide both sides by 2, a is 5. So our equation for our function is y equals a, which is 5, times b, which is 2 to the power of x. A power model we can write using the same basic pattern. Let me make up some new points for that, or copy them down here. My points for my power function are 4, 6, and 8, 15. So the power function in our basic model is y equals a times x to the power of b. Notice in this case the x is the base rather than the exponent, but I'm going to fill out my equations the same way. Y equals 6 when x is 4, and y equals 15 when x is 8. Here again, you could use substitution, but I'm going to divide. So 15 divided by 6 has to equal a times 8 to the b, divided by a times 4 to the b. 15 divided by 6 is 5 halves, or 2.5. A divided by a makes 1, and here I can combine these because the powers are the same. And 8 divided by 4 is 2. Which gives me 2.5 equals 2 to the power of b. This is an exponential equation, so to solve it, I use logarithms on both sides. The base is 2, so log base 2 of 2.5 equals log base 2 of 2 to the power of b. That cancels, leaving just b, and we have log base 2 of 2.5 on the other side. Put that in my calculator. The fastest way is to do log of 2.5 divided by log of 2. That's the change of base formula. And it will give me a decimal approximation of 1.32. Now that I have b, I can go back up to my first equation. 6 equals a times 4 to the power of 1.32. So a will be 6 divided by 4 to the power of 1.32, which my calculator tells me is 0.96. So y equals a 0.96 times x to the power of 1.32. And there you have it. Again, these processes are basically the same. You're going to take your 2 points and stick them in for x and y. You're going to divide to eliminate a, then solve for b. Once you have b, stick that into the other one of the equations to find a, write your function. This year, I'm going to tell you whether you're looking for an exponential or power function model. You're not expected to be able to figure out which one's a better fit yourself for any of these. Moving on to step 2, the other thing we have to do today, if you're given a table of values, usually these represent approximate values, not points that your graph absolutely has to go through every one of these points, but your graph is supposed to get as close to these points as possible. So we're going to use regression on the calculator. The correct place to go to get regression on your calculator when we're putting in a table of values like this is the stat button right here. So I go to stat. To change my values, I'm going to use edit. So the edit column, just choose edit here. If there are values in there already, you can clear them out. Sorry, I had these values in already. L1 is going to represent our X list, and L2 will be our Y list. So the X's are 1, 2, 3, 4, and 5. And our Y's in this case, 370, 417, 460, 523, and 598. Make sure your lists are the same length, and you might want to double check that they line up properly, or you'll have trouble later. In this case, we've been told to use an exponential model. So to do regression, we're going to go back to the stat button. It's under the calc menu rather than the edit menu. And if you scroll down, you'll find the one for exponential regression right here, xreg. While I'm here, I should point out the power regression is right underneath it. You may have to do some power regressions as well. I'm just going to show you the one. The process is the same. Exponential regression, the newer calculators will bring up this menu. The old ones will just say exponential regression, and you can just push enter. You can check your lists, L1 for X and L2 for Y, and then push calculate. It will give you here your basic outline basic formula, a times b to the x, which we've been using. It'll give you the value for a and the value for b. If diagnostics are on in your calculator, you'll also get your r squared and r value. R stands for residual. It's a measure of how far the points are away from your points. A value of 1 is good, a value of 0 bad. These numbers are quite close to 1, so this is a good fit for these points. The exponential model then is y equals a, which is 327, times b, 1.13 to the power of x. So the stat button, stat edit to put in your values, and then stat calc to find your regression model will help you to find the regression model for a given exponential function. Your homework for this section will be on page 533. We're going to do questions 3 through 29, first and last. But I should mention on 23 and 26, the instructions tell you to draw a scatter plot, and I want you to skip the scatter plot. Just use your calculator to find the regression model. 7.7. Good luck.